Thank you, Cameron. Bessie, whenever you're ready.
Hi guys, I'm Betsy, and today I will be presenting or introducing our final product and our website. So, our website was all around the topic of diabetes, and what we really wanted to focus on was some sort of way people can self-evaluate themselves to see whether they're prone to have diabetes or not. So, the why, according to the CDC, diabetes is a chronic disorder that impacts how a person's body converts food into energy. Diabetes slows down or stops the production of insulin, increasing the amount of glucose or blood sugar. This increase leads to heart disease, vision loss, and other serious health problems. Our objective is to spread awareness on the topic of diabetes. It is something that a person can carry through their life without knowing. The purpose of our website is to aid people in self-evaluating to see whether they may or may not be prone to having diabetes. Exploration of our data. Our data is derived with a 2019 diabetes dataset from Kaggle. The evaluated factors include age, gender, family diabetes, high blood pressure, prediabetes, physical activity, BMI, smoking, alcohol, sleep, sound sleep, regular medicine, junk food, stress, BP levels, pregnancies, and urination. And the significance and or extensions of this project could be that it's easy to help detect diabetes and easy to access. And the best part is that it's free and you don't have to pay for it. I will now be passing on to Isaac.
All right. When we were introduced to AI Camp, we were told to create a project based on our interests. So we created a website to help people self-diagnose themselves to see if they had diabetes. For our first week, we just covered the basics of Python and graphing our data. For the second week, we took that data and plugged it in and trained it using machine learning models. And for the final week, we built a website using all the stuff we had learned previously to help people self-diagnose for diabetes.
Now that you have a good understanding of the data set itself and the struggle that came when getting to week 3, and today, the final day of AI Camp, we can finally get into the visualizations. In our first visualization, we compared age and gender, and it was taken into account when determining the overall likelihood of an individual contracting diabetes. This makes sense, as a basic genotypic trait should always be considered in any disease. When looking at this graph, you will notice that both graphs for males and females are exactly the same when discussing their status of diabetes. Though this turnout may not seem like much value, it shows a good scale of what groups of age specifically are more vulnerable than the others. Those in the age range of 40 and lower have fewer tendencies of gaining diabetes, while those older than such range start to contract the virus. While this will play an important role when considering the following graphs. Now that the basis has been set for the individuals, we can start exploring certain factors and how they pertain to each age group. In the next graph, we look at physical activity of the age groups. All the graphs that provide some form of physical activity have those that are 40 and lower being the core leader. This means that there is some sort of correlation between staying physically active and diabetes outcomes. With such a vast difference between physical activities throughout the ages, this factor must be heavily considered when talking about the vulnerability to diabetes. Now that physical activity is out of the way, we can correlate such information into the overall body mass index when comparing the two genders generally. Since we already know that there is no difference when it comes to age and gender, but there is a difference in age and physical activity, it's a good thing to investigate what differences there can be in a phenotypic sense with BMI. According to the National Health Service, being below the BMI of 18.5, you're considered underweight. And if you're within the range of 18.5 and 24.5, you're considered to be at a healthy weight. And if you are in the range of 25 to 29.9, you're considered overweight. When taking a glance at the graphs and the differing genders, blue being male and red being female, you notice pretty significant differences. To compare, the majority of those who underwent this factor test are in the healthy BMI range. However, you'll notice the amount of underweight and overweight BMI testers when comparing the two genders show that those specific factors are found mainly in women. Though we need to double back and realize that ultimately BMI doesn't play a huge or noticeable factor in diabetes as supported in the first graph. Moving along, we can now take a look at quality sleep in relation to stress and its correlation to diabetes. These two graphs don't show much significant difference in the way they are formed, but that doesn't mean sound sleep and stress aren't factors in diabetes. As the red graphs clearly show that there is not much difference in the way the graphs are formed, there's still an overall more prevalence of diabetes forming in those that do not get sound sleep, even without the regard for stress. This is most likely due to the insulin resistance decrease that occurs when someone lacks sleep. But since that isn't inside the graph itself, I won't go into much further detail. Another factor that we investigated to determine if the stress was correlated to diabetes was the effect of smoking on stress. According to those that were tested, the majority of those that frequently smoke report that they aren't under constant stress. We know from science done and from credible sources and the plethora of advertisement to quit smoking that there is some sort of stress buildup over time. However, this graph is specifically meant to show smoking always having stress, which there seems to be very few according to the testers. And when looking at the correlation of these two factors to diabetes itself, there's a minor correlation between the two, but outside factors must be considered as the way someone contracts diabetes is not one size fits all. From one unhealthy habit to another, we also decided to investigate the association between age and junk food when linking them to diabetes. The blue marker shows those who are in the age range of 40 and lower. You can see that in every aspect, the age group consumes the most amount of junk food, but they are also the widest range in terms of ages, so the math checks out. What's eye-opening is that even though they take in the most amount of junk food, they still don't contract diabetes with these unhealthy habits. While the other groups are represented in a scattered fashion throughout, the red markers, they do have diabetes when looking at their junk food intake. This probably goes hand in hand with the physical activity the age groups undertake, which is also in favor of the groups 40 and younger. Even with this information, it's safe to assume that there is some form of correlation between junk food and diabetes. Lastly, we looked at the age groups and their alcohol intake. While this graph doesn't show statistics when considering diabetes, most of the participants didn't drink alcohol, but for those that did, we see that the age range of 59 and younger drink the most amount of alcohol.
So now we're going to start talking about our models. Here you're going to see just the matrix models and then explanation of what the models are and which ones we used. As you can see, we use classification models such as logistic regression, SVM with and without standard scalar, and random forest, since we are predicting a discrete class label. First off, as you can see, we have logistic regression, which calculates the probability of or likeliness of an event happening using a given data set of independent variables, with the dependent variables valuing between 0 and 1. Then we have random forest, which uses decision trees and averages out the outputs to find the final prediction. We also have a support vector machine with and without standard scalar, which are supervised learning models with associated learning algorithms that analyze data for classification and regression problems, using hyperplanes or lines that separate the data into two categories, either having or not having, or yes or no, which is perfect since we're trying to identify whether someone had diabetes or not. As you can see in our matrix models, our true positives for logistic regression, SVM, with standard scalar and random forest are all average around 5-ish, while SVM without standard scalar was the highest, having 60. Now onto our results and conclusions, where we compare all of our models on their F1 scores and accuracy. By taking harmonic mean from each model's position, and we can compare each of their performances, which is basically what F1 looks at and does. As you can see when looking at our graphs, the x-axis will be the models, and the y-axis will be either F1 or accuracy, with SVM being closer to 0.9 compared to the rest, which are closer to 0.8 in the F1 graph, which is the first graph, and the with SVM closer to 1 compared to the rest, which are closer to 0.9 in terms of accuracy, with SVM performing the highest overall. Now let's look at our product.
Yeah, so now to self-evaluation. As you can see here, almost all the categories from the original data set are here, except for diabetic, because that's what we're testing for. So for categories such as age, you have options to choose from that mimic the original data set. And for categories such as BMI, you have to put in a numerical value. So once you put in all the values, the SVM machine compares it to the original data set and makes a prediction based off of it. So now you just press evaluate, and then,
I think our server is not running right now. But ideally it should pops up a text set that diagnosed as diabetic.
yeah.
1 sec.
Okay.
Um, okay. And then you can follow in with the team.
Oh wait, I just want to add something to the self-evaluation.
Oh,
So,
okay.
there might be some complications with the prediction, as the person may not put in the right or correct values about health information, and the machine isn't 100% accurate, although highly accurate. So there might be some complications with that. However, it can make the person make better health related decisions and be more aware of diabetes. Okay, and then after you press evaluate, you just scroll down, and then you should have your diagnosis. Yep, okay. Then onto our team. So we all had very little knowledge on coding, but we wanted to apply it to real world applications. So after 3 weeks, we got our data set and learned about machine learning, the basics of Python, etc., which helped us create this website and aid others in self-diagnosis of diabetes. So there's zero payment needed, as mentioned before, and we hope that you got something out of this presentation. Thank you so much for listening.
Awesome. I'm the instructor. Thank you all. You all did great. I'm great to have you all.